Hi everyone, so welcome to lecture number 10, which is removing nth node from back of a single linked list. Okay, so let's see what does this problem mean. So let's say this is a linked list with the nodes of 5. So here n equals to 5. Okay, so now I want to delete which node? Delete n. Let's say this is a deletion of nth node from the back. I want to delete n equals to 2. So that means, so let me change my color. So that means I want to delete this particular node, right? I want to delete this particular node. Okay, so if you see, if you observe a pattern here, so if it's an n equals to, sorry, if it's a second node from the back, then from forward, how many hops you can make? Let's say now to reach here, let's say you want to delete this particular node. That means you need to break this link and you need to break this link, right? That's it, right? Or else you need to jump to this particular node and you can simply make dot next equals to, let's say this current node will be current node dot next. So you can simply, you are simply ignoring this entire thing. So in this way you can solve the problem, but there are too many edge cases to handle. It may look simple to you at the beginning, but if you look it clearly, like there are some edge cases to be handled. This is in the case of larger number of nodes, right? If you have many number of nodes, if you got a problem, that means if you want to delete a key 2, now let's see how many hops you need to make to reach this position, right? To reach this position, so you can perform this operation, how many hops you should make? Hops means jumps, right? So the delete key is 2 and the length is 5. So how many times you need to move here? First move, second move. That means you need to make 2 moves, right? So which is 5 minus 2 minus 1, right? Which is equals to 2. So these are hops. These many hops you can make to reach this particular node, so that you can simply perform this operation. Let's say now total nodes are 1. Okay, this is a typical question. So let's say the n equals to 1 and your delete node is also 1. Obviously it's 1, right? So what you can do, you can simply make head equals to nil. That's it, right? It's that simple. So let's say there are 2 nodes. So now this is one node and this is one node, and you are going to delete your first node, which is this node, right? So let's say now let's calculate hops first. Let's see what the hops count will be. Let's say it's hops, so the length is 2, right? And which is minus n value minus 1 and minus 1. Hops is 0, right? So that means you should not make any jumps here. Now when you see this, you are at this position, right? So now here current pointer is equals to head, and you can see this clearly, and your hops is 0. Okay, so that means if you want to delete this particular value, then that means you can simply make your head dot next will point to head dot next, right? This is what you need to make. You are going to delete this particular node. If you want to delete this particular node, now let's say there is another condition, which are 2 nodes here, and now n equals to 2. So let's count hops. So 2 minus 2 minus 1, which is minus 1, and your pointer is here, right? You cannot move back, but you need to actually point to the back side somewhere here, right? But there is no node here, but you can say that the current pointer is at head position and your hops is less than 0. So that means you need to delete your head, right? So to make that happen, what you can do, you can simply make head equals to head dot next to solve the problem. So these are all the edge cases which you need to cover. Like this comes when you analyze this, right? So whenever a question occurs to you, make sure to write it down. Like what will be my edge case for first node, second node, and third node, and 4 nodes. So by the time you reach your 4 nodes, you would have get the pattern, right? So now at the first node you got this pattern, and the second node you got this pattern, and third node you may get this pattern, and in 4 you got this pattern. So in this way, so like if you keep on iterating some problem, like with different examples, you will get what are the edge cases there, and then you can simply solve this problem in the same way which I did. Initially I ignored this case, I have ignored this case, I have ignored this case. LeetCode, I have around 3 submissions to pass this problem, so which is high, because at the initial stages I was also struggling with finding the edge cases, but now it's a lot bit clear. So like you need to write down examples so that it makes easier for you. Yeah, I hope you understood how we can solve this problem. So let's jump into our coding session. So let's see how we can write code for remove nth node from the back. So first let's calculate the length of the linked list, and from there we'll calculate the hops, and we'll simply point our current pointer here, and we'll decrement the hops, and from there we'll try to handle the edge cases. Let's say if length is 1, then simply we can mark head as nil, and if let's say if current pointer is head, that means we have 2 cases, either we are going to delete the first node or we are going to delete the second node. So if it's a first, let's say if it's a second node, then we can simply mark the head dot next to head dot next node next. If not, then we are going to delete the head, right? So we are just moving the SLL dot head to SLL dot head dot next, and for all the other cases we are simply moving dot next to break the link. I hope you like my videos, so make sure to like and subscribe. If you have any doubts, please put it in the comment section, I'll be replying there. Yeah, that's it for this video, so let's meet in other lecture. Until then, bye bye.